Hey there! So in this video, we're going to keep building our understanding of the complex numbers, which is a pretty strange topic the first time that we're learning about it. So to make better sense of this, we're going to try to visualize them, see what they would look like as a picture. Visualization is one of the best tools that our brains have for making better sense of things that might be tough to see otherwise. Even just what I'm doing right now, right? Writing is an example of visualization. Writing is a tool that humans created to visualize human language. Or in music, musicians use musical notation as a way to visualize sounds. Or in politics and geography and history, we can use maps as a way to visualize how human societies are organized. So we can do the same thing in mathematics. We have a way of visualizing the real numbers as a number line. So this is a one-dimensional space that has all of our positive numbers moving in one direction and our negative numbers moving in the other. And this is a powerful visualization because it allows us to see relationships between how real numbers fit together with each other. Like we can see that the real number -3 is closer to the real number -2 than it is to 0. But a couple hundred years ago, mathematicians realized that there were certain problems that we couldn't answer just with the real numbers alone. So we had to create another type of number, the imaginary numbers, which exist as the square roots of negative numbers. Now they're called imaginary numbers, but I don't really like that term. It's mostly just a relic of history that at some point they had to come up with a name for them, and they already called the positive and negative numbers the real numbers, so they decided to call these other types of numbers imaginary. But that word makes it seem like imaginary numbers are somehow fake or less proper than the real numbers. And it's true that imaginary numbers are made up in a sense by humans, but then again, so are the real numbers. All types of numbers are just concepts that humans created in our minds so that we could better understand the world. So instead of thinking of imaginary numbers as fake, I think a better way to see them is if we think of them as being like the real numbers, existing along a number line, except this number line exists in a separate dimension. So we have these two spaces of numbers, the real numbers and the imaginary numbers, that each exist in a separate dimension. But there's another type of number that we've seen, which is what we get when we combine together real and imaginary numbers. And this is the space of complex numbers. So how can we visualize a picture of complex numbers? Well, if real numbers are a single number line and imaginary numbers are another number line, but in another dimension, meaning sort of pointed in a different direction than the real numbers, then to put these two spaces together and get a complex number, we can overlap these number lines on top of one another. And that gives us a two-dimensional space called the complex plane, where we can visualize what a complex number looks like. So this looks similar to the XY coordinate axis that you're probably used to seeing with graphing, but there's a bit of a technical difference here, which is when we plot a point on a graph using XY coordinates, that's really a pair of two numbers. We have a real number for x and a real number for y. Whereas when we plot a complex number on this plane, a complex number is a single number that is composed of two parts, a real part and an imaginary part. So it's one number that exists in two dimensions. And here's how the complex plane works. We have the horizontal axis that represents our real number line, and this vertical axis that represents our imaginary number line. So any complex number, for example, this number a that we have here, we can graph by putting its real portion along the real number line. So if I want to graph the real number 4, well, that would be 4 units to the right on our real axis. And then if I want to graph the imaginary number 2i, that would be 2 units up on our imaginary axis. So the complex number 4 plus 2i is what we get by intersecting those two numbers. And this number right here, this point that I'm plotting, that would represent the complex number 4 plus 2i. And let's keep practicing, and let's plot the rest of these numbers on our complex plane. So in example B, we have -6 on our real axis. So I'm going to go over to -6 to the left on our horizontal axis, and then plus I, that's 1 unit up on our imaginary axis. So point B would be here on the complex plane. Point C has a real part that is +3, so that is going to be 3 units to the right on our real axis, and its imaginary part is -5i, so 5 units down on our imaginary axis. So the complex number 3 minus 5i is this point right here. Well, what about the number 6 by itself? That's just a real number. We could also think of it as a complex number where the imaginary portion is 0. So that means that we will have a point at +6 on our real axis. And since the imaginary portion of that complex number is 0, we're not going up or down at all on the imaginary axis. And the complex number -3i that we have in example E, well, we can think of that as a complex number just where the real portion is equal to 0. So we're not going to move at all left or right on our real axis, but we will go down 3 units to get to -3i on our imaginary axis. So to summarize what we've seen so far, we took these two separate number spaces, the real numbers and the imaginary numbers, which are each one-dimensional number lines. And when we combine them together into a two-dimensional space, that gives us the complex plane. Let's practice with a few more examples so that we can understand the complex plane. And this time we're going to start with the visual and then see if we can write the complex number using symbols. So we have this point P, which on our real axis looks like that is 4 units to the left. So the real portion of that number is -4. And on our imaginary axis, point P is 2 units down. So that represents the imaginary part, imaginary -2 or -2i. point Q is 2 units to the left on the negative side of our real axis. So its real component is -2, and it's 3 units up on the imaginary axis. So its imaginary part is plus 3i. And if we have a complex number that is plotted along one of our axes, touching that axis, then that just means that either the real part or the imaginary part is 0. So example point R has a real part that is equal to 0. It's not to the right or left on our real axis. And its imaginary part would be -1i. So we could write this complex number as 0 minus I, or just minus I. And point T has an imaginary portion that is 0 because we haven't moved up or down at all on our imaginary axis, and its real component is equal to 4. So we could write this number as 4 plus 0i, or just 4 by itself. So in practice, graphing or visualizing complex numbers is sort of like graphing x-y coordinate pairs. But conceptually, there is a difference that an x-y coordinate pair is a pair of 2 numbers, whereas a complex number is a single number that has 2 dimensions.